Is it possible to travel back in time? Do you think you can someday go back in time and meet your great-grandparents? Or better yet, what do you think would happen if you just brought back your grandparents to the present? Some might say that would be a dilemma. If you do so, you would not exist. So it's a contradiction. Such questions and so many more make us wonder if time travel is really possible. And if it is, how would we travel back in time? We have all these questions and no answers at all. However, we heard of something that might intrigue you. NASA's $10 billion ultimate time machine. Wait, so are they actually building a time machine? Let's find out. NASA's $10 billion time machine actually refers to the James Webb Space Telescope, a cosmic time machine that will be detailing every major event in the creation of the universe. From the formation of the earliest galaxies, the cosmic backyard of our solar system, and even answer the question if we are the only living beings here. This is a joint venture with the ESA and the CSA, and this groundbreaking telescope was actually planned to be developed in 1996. You have surely heard of the Hubble telescope, right? According to NASA, the JWST telescope will go above and beyond the Hubble. The mirror itself is about 6.5 meters across, compared to the Hubble's 2 meters. Once launched, the JWST will travel over 1.5 million kilometers to a gravitationally stable outpost, which is called Lagrange 2. This outpost lies on a straight line from the Sun to Earth and beyond, which means that the JWST will be locked into Earth's orbit around the Sun. Unlike the Hubble, which orbits the Earth, the James Webb Telescope will be going in and out of our shadow every 90 minutes, which will help capture unobstructed views of the universe. However, the new telescope's far-flung location also means that, unlike the Hubble, it will be unserviceable. The team expects that science observations will begin nearly 6 months after the telescope is launched, which means it will not be until next year that we start receiving any information. This billion-dollar telescope has features that make it exemplary. A near-infrared camera, a combined mid-infrared camera and spectrograph with a cryo-cooler to keep its temperature, a fine guidance system, and a wide-field imager that includes a mode for exoplanet spectroscopy. But you must be asking, why are we calling this a time machine? Which it isn't. Well, in a way it is, because the JWST will help us see events that happened in the past. Let us explain. When Hubble was launched 30 years ago, it was the first space-based optical scope, and it has given us unprecedented views of the universe. However, it looks at the optical, ultraviolet, and near-infrared wavelength ranges. Because of the finite speed of light and the very vast distances of space, when we see light from the earliest galaxies, that light left a long time ago on its journey to our telescopes. So at present, we are seeing back in time to when the universe was young. Even though these galaxies are very distant, they are actually very young when we are observing them, and their light has been redshifted by the expansion of the universe. The light left those very young galaxies as ultraviolet and visible light, but the expansion of the universe has stretched its wavelengths into the infrared. That is why we have optimized the Webb telescope to work there. James Webb will look between visible red and mid-infrared light, peering much further back into the early universe. How does this work? Light from the earliest luminous objects travels so far in an expanding universe that by the time it reaches us, its wavelengths have been stretched or redshifted. This means that the earliest universe is observable only in the infrared part of the spectrum. Thanks to its infrared camera and spectrometer, JWST is equipped to do this task well. So what do you think this telescope might find? The scientists involved in the project have a lot of high hopes, and so do we. The primary purpose of this telescope is to investigate the so-called end of the Dark Ages, after the Big Bang, when the universe began to fill with the first light from newly ignited stars. Interestingly, it should be able to look back to 100 to 250 million years after the Big Bang, which we do not know anything about yet. However, like its little brother Hubble, it is also a general-purpose observatory and will specifically look at the birth and assembly of galaxies, the effects of black holes, and the origins of life. Scientists are hoping JWST will help us better understand the size and geometry of the universe, throwing light on dark matter and dark energy, and help us understand the ultimate fate of the cosmos. In fact, there are already a list of tasks laid out as soon as the JWST is up and running, such as to observe the atmospheres of potentially habitable, rocky exoplanets in the 7th planet system of TRAPPIST-1, which is 39 light-years from the Earth. Now, coming back to the question of an actual time machine. Would you believe us if we said that we can make things travel backwards and forwards in time? Let us talk about cosmonaut Gennady Padalka, a man that we could safely say traveled through time. You must be aware that Einstein's universe-defining calculations brought us to a very important conclusion. Time is elastic, and dependent on speed. Slowing down or speeding up depends on how fast an object or person is moving. When Padalka completed his 6th mission in space and broke the record for the most cumulative time spent beyond Earth's atmosphere, the total of 879 days orbiting the planet at high speeds, Padalka also became a time traveler. How did that happen? It's simple. Thanks to Einstein's theory of relativity, when Padalka came back from his adventures, he found the Earth to be 1/44th of a second in the future of where he expected it to be, which basically means Padalka actually traveled into the future. So does this mean we could attempt to make a time machine? The answer would be yes and no. The major dilemmas we would face are sizes and speeds. Padalka's jump into the future was so minuscule because he was traveling only at 17,000 miles per hour. Yes, we know that is fast, but it is not so fast when we are talking on time traveling scale. What would happen if we could create something that could go much faster than geostationary orbit? We are not talking a commercial jetliner or a 21st century rocket to the ISS, but something that could approach 186,282 miles per second. Surprisingly, we have already done that as well. Subatomic particles are routinely sent into the future in the Large Hadron Collider. But humans are a totally different matter. The enormous amount of energy that would be needed to propel a ship that fast and ensure the safety of the time traveler are just some of the problems we would face. But scientists believe that building a time machine is possible. Many astrophysicists, such as Ron Mallett, believe that with then proper funding and dedication, a time machine could actually be built in the next 20 years. For now, time travel enthusiasts will have to stick to sci-fi movies, although the future does not seem bleak. We have a telescopic time machine in space that will answer so many important questions, and the scientific community is holding a great amount of hope for a time machine in the near future. Do you think Mallett is right? Could time travel become a possibility in just a few decades? And what do you think the JWST will discover during its time in space? Please share your thoughts with us. Please share your thoughts with us. Also, if you enjoyed the video, make sure to like it and subscribe to our channel for more interesting content. See you soon.